Question 1 is just about getting familiar with your own calculator. And when you type these in carefully, you should get 135, 45.88, and then just be careful that you put that in brackets and you would end up with a 12. And even if you wanted to work it out yourself, root 9, so that's 3, and you need to multiply that by what's 7 minus 3, so that's 4, so 3 by 4 is 12. The next bit is just about, being able to reason out 4 years' time, people's ages. So if he's 16 now, 4 years on from that, he'll be 20. If he's 12 now or she's 12 now, 4 years on from that, he'll be 16. And same here, he'll be 15. What's the mean age? Your mean age in 4 years' time. So we're looking at this piece of data here. The mean is add them all up and divide by however many there are. So we're going to add up the 20, the 16 and the 15, and that'll give me a total of 51. And I'm dividing by 3 because there are 3 pieces of data, which gives me an average of 17 years old. The next one is about you have some money, you get some change, and working out the value of the bar of chocolate. So firstly, they get 20 euro, but he gets 13.40 in change. So I can work out straight away by subtraction there and get my starting marks that 20 minus that 13.40 is 660. So altogether he pays 660 for the 3 bars. And we need to then divide that by 3 to find the value of 1 bar of chocolate. So €2.20. Now, if you made a little error and you didn't realise that that was the change that he got and you divided that by 3, you'd still get some marks, but just take care when you're reading the question is all. This is a ratio question, and when we looked at ratio, we said important thing is that we know how many pieces of, whether it's a cake or a pizza or money all together. So showing that all together, we need at least 5 pieces of the puzzle, hopefully, or 5 pieces of the money or the cake. Then we can work from there. So if I need to divide this into 5 pieces, then that's 13.40. I need to divide it by 5, which is 268. So 1 piece is 268. So Noah gets 3 pieces of that, and Amy gets 2 pieces of that. So that's 804, and then the rest is 536. And I'm just going to put that in here. Okay, the next bit, use a ruler inside an exam. Okay, make sure that even if it isn't a ruler, it's a straight edge. Okay, so if you have a calculator, you could even use the calculator to draw your straight lines. Make sure it is neat. So you can draw your bar chart there, or your histogram, and they have it ready for me to do. So I know here I'm going up as far as 12 for that bar, etc. Find the total number of customers who visited the cafe on that day. Well, here's the number of customers. So I just need to total that up. And when I total it up, I end up with 78. So again, calculator work. Take your time with it, and you can always double check it if you're unsure. This was an interesting question. The greatest possible number of customers who could have spent less than 15 minutes. So these definitely spent less than 15 minutes. And these possibly spent less than 15 minutes because they spent somewhere between 10 and 20. Sorry. So they spent somewhere between 10 and 20. So the greatest possible number is definitely these and possibly these. So if we want to talk about maybe all of these, that's the greatest possible number, because it is possible that all of these people spent less than 15 minutes because we don't have the accurate data. We know they spent somewhere between 10 to 20. So the greatest possible number is the 30. Next, we want to work out the area of the rectangular flag in centimetres squared. So area is length by width. So that's 100 times the 60. (6,000) centimetres squared. And the flag has a circle inside the rectangle that has a radius of 21. So we know the radius here is 21. Work out the area of the circle. So this is the area of a circle formula. Hopefully, if I just take the formula and I carefully fill it in, I should have my answer. So the area I get by multiplying pi by the radius, which I know to be 21, and then I square it with the little 2 on top. I need to know where all these buttons are on my calculator. So down here for me is the pi button in yellow. 21 squared, and I got 441 pi. Now, I might leave it like that, except the question said, give your answer correct to the nearest centimetre squared. So again, I'm using my calculator to go, that's the same as 1385.44 ... And if I round that to the nearest centimetre squared, 1385 centimetres squared is the area. Some Venn diagrams here. We cannot have, when we total up here, 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 and here, more than 120. It tells me there are 120 students in the survey. 30 played both, so they seem to fall in here. That's usually the place that you want to go for first. Now, if 30 played both and 48 are in here all together, I have to be left with 18 there. How many students play neither sport nor computer games? So that's these 37 out here. Now we have 2 symbols here, so I'm going to do what's in the brackets first. I'm going to have a look at S less C. So that means, and I have to explain this in terms of what the students in the school play. So I have to talk about the sport and the computer games. So it seems as though the ones who play sport but not computers. So that's the first thing. That's that symbol. If you go to your log tables, you'll see it says it means less or get rid of. So I can use the log tables to help me in this situation. S, less, C. They play sports, but don't play computer games. And then we look at this symbol. This isn't in the log tables, so I'm hoping that this will stick at some stage in your mind, that means the cardinal number, or it just means the number of people in this group. So the number of students who play sport but not computer games. And here we're looking at probability. How do I do probability? Usually I have to make a fraction. So what I want over the total. And a student is picked at random from the 120. So it is out of the 120. What is the probability that this student plays sport or computer games, but not both? So this is both. So these are the ones that play sport only, let's say. These are the ones that play computer games only. So if I'm looking at these two, but not both, then I'm looking at the 35 and the 18, which gives me 53 out of 120. You can throw that into your calculator and see if it simplifies. It doesn't in this situation, but you can always check. So that's my answer there. A bit more, maybe calculator work here if you need to, or you could do out the full list of how many different choices of running shoes does she sell in the shop. So, for example, one choice would be B and yellow. So another one would be A and yellow, C and yellow, A and red, B and blue, A and blue, etc. You could do out the full list, but do it a bit more methodically than what I just said there. So it might be A and red, A and blue, A and black, A and yellow. And even before you finish your list, you might actually realise that 3 times 4 gives me 12. So that's just called the fundamental principle of counting. You are looking at how many options here, and we're multiplying. But even just listing out all your options and counting that would still bring you to the answer 12. Tom writes down a list of 5 numbers from smallest to biggest, and we're given 2 below. The mode of these numbers is 5. Sorry, the mode of these 5 numbers is 2. So mode means most common or most frequent. So there has to be at least another 2 here, if not a third one. Now, I'm just going to leave it as 2 there for the minute and see what else I can work out. The median, so that's the middle number of these numbers, is 7. So if you crossed off first, last, until you get to the middle number, you'd be left with 7. So I'm hoping this will all work out. And the range is 12. So the range is your difference from your highest to your lowest. So if the difference between this number and this number is 12, this has to be 14. Now you might want to double check everything there in case there's anything I need to tweak. So is the mode 2? Yes. Is the median 7? Yes. And is the range 12? Yes. And this is looking at algebra, but in a different way. So in this question, each shape has a fixed value. So it has to be the same number here for all 3 because it's the same shape. So some number plus the same number plus the same number gives me 21. So we're looking at 7. Now that we've worked out that that is 7, now we can have a look at this and go, okay, so that's 7. and that's 7. So that in total is 14, plus what gives me 18. And now we're looking at two equations, and we need to work out the value of this shape and the value of this shape. Two of these would give you 24 along with the square, and one of these along with the square would give you 13. So we can guess and check here, or we could do a simultaneous equation. I would think that the easiest thing to do is hopefully try, guess and check, and if I get stuck that way, we could do the simultaneous equation. So if I look at these two numbers, it could be 10 and 3. Now, does that work up here? So if that was 10 and that was 3, does 10 plus 10 plus 3 give me 24? No. So maybe we'll go for 9. Maybe 9 and 4. Because again, 9 and 4 does give me 13, but let's just check. Does 4 plus 4 plus 9 give me 24? And so a minute ago, I was doing 3 plus 3 plus 10. Does that give me 24? No. Here it's 4 plus 4 plus 9. Does that give me 24? So 4 and 4 is 8 plus 9 is 17. No. So it seems as though I'm maybe headed in the right direction, that this number is bigger. Because I'm getting, when this number is bigger and this one is smaller, I'm getting closer to 24. So let's try 8 and 5. So if this was 8, so just in case. So the 5 there plus the 8 does give me 13. So that's where I'm getting that from, my original guess down here. And now I'm looking at this and I'm going 8 plus 8 plus 5. So 8 and 8 is 16, plus 5 is 21. No, but we're definitely getting there. So maybe we try 10. So this is 10, I'm suggesting, and this is 3. So it's the opposite way around from how I started. Now, like I said, this might take me a few minutes, and if it's taking too long, I'll try and use an algebra method. Because algebra is about finding the missing number, so this can be done by algebra. So if I said this was 10 and this was 10, so that's 20 and 3, that's 23, very close. Let's try 11 and 2. So if that was the 2, if that was 11, does that work here? So 11 and 11 and 2. 11 plus 11 is 22, plus 2 is 24. That works for both. That's my two answers. So in this situation, that is 11 and that is 2. So that can be done completely without algebra, just by taking your time and working it out and logically starting to narrow it down and go in the right direction. This is saying find the value. Another word for that would be evaluate. So find the value of 3p's plus 7q's. Now what does 3p mean? It means 3 multiplied by p. And if they're telling me that p is 2 and q is 11, then I can say 3 times 2 is 6 plus 77 altogether gives me 83. So they've given me some algebra, but this is a very nice question. They've told me what the missing numbers are. Sometimes they don't tell me. Sometimes they want me to work it out. But if I can't, I can't. And in this situation, I don't even have to try and work out the missing numbers. They've given them to me. So this is an extra nice question. I just hopefully understand what 3p plus 7q means and I throw it into my calculator. So they want me to multiply out and simplify here. So to simplify means just to write it in a simple way. Again, I'm hoping in algebra to find the missing number, but sometimes I just can't. The best I can do is write it as simply as I possibly can. So here I would end up with 10a minus 6, and then that's all that the 2 is being multiplied by. The bracket is closed now. So I've done my multiplication and I just write down the rest. And now I see again, is there any way for me to write this in a simpler way? If you have 10 A's and you lose 4 of them, you're left with 6a. If you have a minus 6 and you add 7 to that, again, just let the calculator help you there. You end up with a plus 1. So 6a plus a 1. Now, here we're getting on to where they want me to solve the following equation. So if you want to, you could do it by little pictures. There's 8y's plus 4 numbers, or 4 units. Here we have 2y's, and we lose 8 units. And if we want to find out what y is, well then we probably want to, so in the end, we want to be able to tell them, solve the mystery, y equals. So we probably need to get the y's on the same side. So if I get rid of 2 y's here, then I need to also get rid of 2 y's here. Another way of saying that is if I bring this over, it becomes a minus 2y. Which leaves me, now that I've blocked out the 2 y's, or I've taken them out of both sides, because we need to keep balance in an equation, I'm left with 6y plus 4 equals minus 8. Again, I'm hoping to eventually get to y on its own, so I'm going to move that 4 over, it becomes a minus 4. Or the way you might look at it in the drawing is if I remove 4 units from this side, I have to remove 4 units from this side. I end up with 6y is equal to minus 12. And now 6 times some number gives me minus 12. I can bring the 6 over, it becomes division. And when I throw into my calculator minus 12 divided by 6, I get minus 2. Okay, so opposites are a great thing here. Because if you look at it, if you don't want to do the drawing out and work it out bit by bit, the plus 2y comes over, becomes a minus 2y. The plus 4 goes over to the other side of the equals, becomes a minus 4. The 6 is being multiplied by the y. It goes over, the opposite of multiply is division. So you can either work it out logically, you know, maybe you prefer images, you're a visual learner, or you want to use your opposite rules in algebra. Either way, you'll still get minus 2. And then this is a method that we just need to write this as its factors. So if we look at 21, they've already given me the 3, so 3 times what gives me 21. So that's 3 times 7. X multiplied by what gives me x squared, sorry. So x multiplied by what gives me x squared, it's an x. And then we need a minus by a minus gives me a plus.